Hello and welcome to the IET 150 show. It's episode 2 and what a show we've got lined up for you. I'm Bobby Seagull, maths teacher, TV presenter and lover of all things engineering and technology. And with me for this epic week-long festival of all things engineering and technology is the IET's very own celebrity TV star and current president of the IET, Danielle George.
Hi Bobby, thank you once again for the fantastic intro. I'm still not sure about the celebrity bit, but we'll see by the end of the week, shall we? For those that don't know me, I am currently the Associate Vice President for Blended and Flexible Learning and a Professor of Radio Frequency Engineering at the University of Manchester. And I was honoured to be made President of the IET in its 150th year. Now, once again, Bobby, we have got another jam-packed show today, haven't we? From climate change and green cities to sustainable fashion, the future of electric motorsport, and even soluble food packaging.
That's got me excited. We'll also be looking back at some of the difference makers of yesteryear, getting hands-on with experiments that you can do from the safety of your own home. And we'll be seeing 150 show resident chef Andrew get his hands dirty in the kitchen with a spot of baconeering. Hello and welcome back to the 150 show from the IET's London home, Savoy Place. Over the next hour, we'll be talking all things sustainability and looking at how engineering and technology are helping to shape a greener planet Earth. Global warming is quite literally a hot topic. Though the process of global warming may not be big news, the projected impact of what could happen in the future often makes front pages and news headlines.
Yeah, you're absolutely right, Bobby. And in 2019, the UK government announced its ambitious new carbon net zero target, becoming the first major economy to legislate for net zero emissions by 2050. And so we'll be speaking to MP Darren Jones to find out just how ambitious these plans are.
Yeah, we'll also be joined by sustainability geoscientist Professor Chris Jackson, who will give insight as to how thinking like a geologist could help us fight climate change. Where else have we got, Dan?
Well, in a study conducted by the charity Oxfam, it was reported that 11 million garments, 11 million, end up in a landfill each week. Can you believe it? 11 million. And while buying second-hand clothes helps to slow down the fast fashion cycle, there has been pressure on fashion outlets to adopt a new mindset, trying to think differently in regards to their design and manufacturing processes. The industry alone accounts for 10% of global carbon emissions. So we'll be joined by Helen Lax, Director of Fashion District, to find out why sustainable fashion is not just important to all our futures, but also good business sense as well.
Absolutely. Do you like a bit of motorsport, Dan?
Oh, I do, yes.
Yeah. Well, there's been plenty of skepticism about Formula E since the first series launched. But as the world looks to move away from fossil fuels when it comes to all forms of transport, could Formula E teach Formula One a few lessons? DS Techeetah team Principal Mark Preston will be with us later on to give us the answers.
And on top of all of that, Andrew will be back in the kitchen with his brand of baconeering. What treats have you got in store for us today, Andrew?
Well, today it's all things sweet. It's caramel bridges and edible reinforcement, structural engineering.
Oh, fantastic. Don't forget to save some for us.
Yes,
We need
love
some.
a bit of caramel.
Yum, yum, yum. All week we're joined by IET STEM Personality of the Year, Callum Daniel, who is here to help inspire the budding engineer and all of us with experiments you can do at home.
And from one global star to a global weather map, we also have Mark to help us bring engineering news from around the world. Mark, where are you taking us today?
Well, after that lovely intro today, Dan, we'll be zipping over to the Far East, the Americas and Europe for another amazing weather map of news, so stay tuned.
Absolutely. Well, as we have previously mentioned, the IET turned 150 this week, and this anniversary gives us a fantastic opportunity to celebrate its rich history. And yesterday we spoke with the IET's Chief Executive, Nigel Fine, to find out what this milestone really means.
Dan, we do a huge amount, but we try to encapsulate it in delivering against our vision, which is very simply working to engineer a better world. And we deliver it through inspiring the next generation of engineers and technicians, informing the engineering community about the developments in engineering, and influencing people who have to know about what engineers do and appreciate the work of engineering. The IET today is not the same as the IET 150 years ago.
Yeah.
We keep reinventing ourselves, and we need to reinvent ourselves as the world around us changes so that we are appealing to newer audiences all the time.
Oh, it's great to hear from Nigel there, wasn't it, and his views there. And right from when I first left university, the IET and engineering has been a fantastic focus for me. I actually studied astrophysics, but I knew I wanted to go into engineering, and so my first input with the IET was a lot more about the courses that the IET did, and it was brilliant. And now it's just great to have those networks and the communities globally as well. And the engineering and technology communities are really now focusing on how to bring sustainability into everything that we do. And I think it's vital that institutions like ours drive that message and really lead from the front.
Thank you. So we have a great video to show you now, presented by our own newsman himself, to tell us more about the UK's drive to cut carbon emissions by 2050.
Climate change has made headlines in recent years, prompting governments to take action. In June 2019, the UK became the world's first major economy to set a target of reaching net zero by 2050. But what does the term net zero really mean? Put simply, net zero refers to the balance between the amount of greenhouse gases produced and the amount that's removed from the atmosphere. We reach net zero when the amount of greenhouse gases we put in is less than the amount we take away. With the target set, just how ready are we? Recent research has shown that in the UK, only 7% of engineering employers believe they have the relevant skills to achieve net zero. And around the world, governments are having to deal with the twin challenge of revitalising their economies whilst also dealing with the effects of a global pandemic.
Unexpectedly, global lockdowns have resulted in improvements to air quality and reductions in carbon emissions. This, along with a higher profile of the climate crisis, has brought the challenge of responding to climate change into sharp focus. The responsibility to drastically reduce our impact on the climate falls on all of us, but engineering has an important role to play. Specialist skills will help us solve and prepare for future challenges, such as pandemics and climate change.
To better help gauge the current state of skills in the engineering and technology sector, the Institution of Engineering and Technology conducted a survey of businesses, focusing on the skills requirements to achieve the government's target of net zero by 2050. The survey found that though engineering employers understand their responsibility to climate change and are taking steps to improve sustainability, only a slim majority have a sustainability strategy, one with specific activities and goals helping their organisations reduce their environmental impact. However, there's no definition of what a sustainability strategy actually looks like.
There are several challenges that continue to hold businesses back, including finding job applicants with the necessary technical skills. This leads to employers favouring reskilling or upskilling their existing staff instead of finding graduates or apprentices. Cost is another obstacle, with 3 in 10 employers citing either increased operational costs or initial investment costs as a barrier to lowering their environmental impact. So how can the industry, government and academia achieve the government's net zero targets and provide a workforce that's fit for purpose? The answer isn't a single solution, but requires a collaborative approach. We must ensure that young people understand the net zero challenge to improve work readiness of new recruits. Industry and educators need to work together to prioritise work experience and deliver training, placements and apprenticeships. Government and industry need to work with educators to build a more flexible and agile workforce, one that supports innovation and drives down cost.
This will allow businesses to reach their net zero goals, equip young people with the relevant skills, and decrease our current recruitment difficulties. Reaching the UK target of achieving net zero emissions by 2050 remains a vital objective for all of us.
Looked like a cold day in March in that field. Joining us now is Member of Parliament for Bristol North West, Darren Jones MP. Hi, Darren.
Hi, Darren. Hi.
Hello.
Thanks so much for joining us. Let's start by asking you, why is it important that the government is pushing to achieve net zero emissions?
Well, we have to save the planet from climate change, which is a pretty good goal, and Britain needs to play her role in that, not just domestically for our own country, but to provide the international leadership that we want to show other countries around the world.
So one of the things is that we have a 2050 net zero target. Is that feasible?
Absolutely, net zero by 2050 is feasible. The Citizens' Assembly on climate change recently showed that, and the Committee on Climate Change have showed us how to do it. So now we've just got to get on and deliver it.
That sounds like a really bold statement, Darren. What are the costs and the benefits of reaching net zero by 2050?
There's no denying that this is going to be a significant amount of change for people. So far, we've managed to create electricity from wind turbines without people really noticing. But in the future, we're going to need to change the way we heat our homes, the way we travel in our cars or on buses, and probably some lifestyle changes around international travel and food choices as well. So it's going to become a much bigger issue for people in their lived experiences every day. And that's a big task. It's going to be difficult, but we have no choice but to do it.
Yeah, sort of big but important changes ahead. So what sectors are going to be most affected by net zero?
Well, we've made great progress so far in generation of power, so electricity. We've now got to really sort out heating in our homes and in our buildings, where we currently burn gas. We need to move away from that to either heat networks or heat pumps or possibly even burning hydrogen. But we've also then got to insulate our buildings so we don't have to burn so much in the first place. So that's going to be the lofts and the windows. And then we've got to solve transport. In terms of combustion engines with electric vehicles and clean buses and long distance travel. And then we've got to decarbonise industry as well. And those are all big jobs, but I know we can do them and we've got to do them. So we need to get on with it.
Yeah. What role do organisations like the IET, but also the government as well, what role do we all play in helping to increase the understanding of the huge role of engineering and technology in our everyday lives?
Well, no one organisation is going to be able to deliver this by itself, including the government. It requires a huge national effort over many decades to make the progress that we need to make. So the IET's work in promoting engineering and technology means we'll have the people with the skills across the whole country who are going to have to do this work in every single community. And we need people to be excited and motivated and skilled up, ready to do that. Otherwise, we're not going to reach our targets in time.
Brilliant.
Yeah, it's really great to see MPs getting behind this serious issue. Climate change has been in the news more and more recently, especially as emissions have dropped so much due to grounded aircraft and less use of transport. But as we move back to some form of normality, how will we halt the catastrophic impact that it could have in society? So many front pages are asking, is it too late to prevent climate change?
So it's not too late, but we do have to make significant progress in this decade. So we've got the net zero target by 2050, but if we're going to limit global warming to 1.5 degrees above pre-industrial levels, which is our target globally, we need to see some significant action before the end of 2030. So we don't really have time to continue to keep talking about this. We've got to get on with it. And I think a lot of the public agree with that. We've seen in polling they want us to do so.
The absolute vast majority of scientists agree that while we can't stop global warming overnight, or even over the next several decades, we can slow the rate and limit the amount of global warming by reducing our emissions of heat-trapping gases. What's your thoughts on that, Darren?
Well, you're right that the world is warmer than it was in the past because of human emissions. I mean, human-derived emissions with carbon. I mean, that's settled science now. The challenge for us is how we limit that temperature growth. And in the Paris Agreement, when the world came together 5 years ago, we wanted to limit that to as close to 1.5 degrees C above pre-industrial levels as possible, and that's the target, limiting the growth in global warming. And we know how to do that. We just have to come together as a world and agree how to do it and get on with it.
Yeah. Collaboration, isn't it? That is the key for this. Yeah. Thank you so much for joining us, Darren. Really insightful stuff. Thanks so much.
The geological record, which refers to all the layers of rock strata, reveals information about the history of the Earth. its past climate, geography, geology, and the evolution of life on its surface. So studying this history shows us how the Earth's climate has changed in the past, how it may change in the future, and the likely impact of carbon emissions.
Professor of Sustainable Geoscience and a fellow staff member at the University of Manchester, may I just say, Chris Jackson focuses his research on the application of geophysics to understand a wide range of geological processes, from sedimentary to magmatic. His fieldwork has taken him to remote and physically and mentally challenging locations, including the Argentinian Andes, the Borneo rainforest, and the Sinai Desert in Egypt. And he's also in Norway now.
No way. Chris is a passionate teacher and communicator. I actually first met him in a sort of cameo role in the 2019 Christmas lectures. And the year later, I was amazed when they announced in 2020, Chris would be the first black person to host the Royal Institution Christmas lectures. So it's an amazing honour to talk to you. We've got another Christmas lecture here.
Surrounded by them here.
Future, 10 years' time. Well, the Christmas lectures are a science lecture series that was started by Michael Faraday in 1825, and who has a lecture theatre in this very building named after him. So, Chris, we're really honoured to have you with us.
Hi, Chris.
Hello, how are you both? Are you well?
Yeah, good, thanks. Yes, yeah. I mean, it sounds incredibly complex when we introduce you, doesn't it? How do you describe what a sustainable geoscience does, and why is it more important to society everywhere now more than ever?
Well, I think at the moment we've got a number of challenges related to how we live sustainably on the Earth, and that is how we utilise resources and how we protect ourselves and keep people safe from natural hazards. So, so-called geohazards. And what I'm interested in, and a number of researchers I work with, is how can we use our geological understanding? So that's how the Earth works, the dynamics of our planet, how the Earth moves and how earthquakes are generated, how volcanoes erupt, how we explore for water and minerals that allow us to build iPads and, all the computing things that are integral to our lives. How we use that understanding to to improve our livelihoods around the world. So it's bringing together just a fundamental understanding of how our planet works for a purpose.
And your work, Chris, I mean, it literally takes you all over the world, doesn't it? Like you say, you're in Norway now, not that we're very jealous at all. But tell us about some of the places you've been and some of the things you've discovered.
Yeah, so I've been really fortunate through my job to travel, because the rocks are kind of indiscriminate about where they're exposed at the Earth's surface, of course. So we go to where the rocks are. Yeah. I've been doing fieldwork recently in the Argentinian Andes, so on the border with Chile, to go and look at some rocks which are about 150 million years old and were deposited in 3 kilometres of water, right? So it's kind of about a place many, many hundreds of millions of years ago. I've also worked in the Egyptian desert, so the Sinai Desert, for my PhD, and that's an area where the Earth's crust is being pulled apart, so it's a rift valley. And what I discovered there was that, the landscapes we actually see present day in the Sinai Desert actually are very similar to the landscapes that were there about 20 million years ago, so not much has changed. So, very fortunate to go and look at lots of different rocks in lots of rather exotic locations.
Yes.
So you're quite literally, Chris, a rock star. Wait, what's been the highlight of your career so far? And what would you say to the younger generation who are interested in green jobs?
I think to your first bit of your question there, the highlight of my career so far has been really being able to go and visit all of these places and have a lot of cultural enrichment, right? So I'm interested in the rocks and, the structure and evolution of the Earth as a scientist, but I've got to interact with lots of different types of people when I visited these different places. And also through being a PhD supervisor and teaching at the university, I've got to interact with a lot of people. So there's a lot of additional things I feel have been brought to me as a person by the people I've interacted with, not necessarily through the science I've done. For the future generation who are interested in green jobs, just be aware that geosciences is a really good route into that. Geoscience is going to be integral to us achieving many of the UN Sustainable Development Goals. So a lot of things related to resource security, related to geohazards and protecting people's lives and livelihoods are going to be kind of solved or tackled by geoscientists. So you can really play an important societal role in the future.
And Chris, you've got a family, haven't you? Do your kids get involved in this? Do they love your work?
Yeah, I sometimes use them as scale bars, right? So if there's a nice piece of rock and I need something to kind of portray the scale, I'll put one of my small children in front of the rocks, and then I'll take a picture, and they'll think, yeah, I'll be just like, oh, just look at the rocks for a second. So I just hid them into it. But no, I mean, more seriously than that, you know, there are gateways into geosciences, right? So the big ticket items like paleontology, dinosaurs, volcanoes, they draw people into the discipline. And then from there, once we've got them kind of hooked on this deep time perspective, how we read the rock record and the paleontological record, then we can start to interest them in lots of other things to do with geosciences as well. So I am secretly kind of tricking them into liking geology.
Yeah, stealth-like, brilliant, absolutely brilliant.
So Chris, what's the best bit of technology that you've been using?
That's a very good question. I mean, drones have been really kind of central to collecting lots of digital data, so geospatially located data. So by that I mean data which you can actually put in a very accurate position on Earth and go back to. And also drones allow us to access bits of rock that are inaccessible to us because it's dangerous to go into these places, so we can fly up and collect data. I think, though, still central to many geologists' toolkits are pens and pencils and notebooks and compasses and things that allow us to record information. And nowadays that's done digitally, of course, with iPads and things that we can take in the field. So we can have GPSs talking to our iPads rather than a compass talking to our paper notebook. But these things, you know, these things are kind of incremental benefits, but they are based on kind of old ideas and old ways of collecting data. So we use the old and the new.
So you have rock, maybe paper, some scissors as well.
And stones. I see where you're going. Yeah. Oh, Chris, we won't let you be subject to any more of Bobby's jokes. Thank you so much for joining us. It's been such a pleasure to talk to you.
It's been an absolute pleasure to talk to you too. Thank you so much for having me on.
Thank you. Oh, there's so much to love about Chris's work, isn't there? But it's also about how he explains such complex ideas and he manages to make them so easy to understand. And what a great job. He's definitely seen some amazing sites all over the world, hasn't he?
Totally. And that's the amazing thing about STEM careers, isn't it? They're so transferable. You can really work anywhere in the world. You can work in the Savoy place in London, or you can work in Norway, and you can combine your career with your passions.
Yeah, absolutely.
Our next guest, Chai-Lun Cheng, a robotics engineer with a passion for climate change, has a vision to keep Singapore both sustainable and livable. Having lived in Singapore throughout his life, he has witnessed the country shift from a developing country to becoming the green garden city that it is today. With Singapore being the second most densely populated country in the world, the government continues to push sustainable goals, which has driven creativity and innovation within both engineering and the tech space.
Hi, Chai-Lun. Thanks so much for joining us. Now, tell us a bit about what it's like to grow up and live in Singapore.
Singapore is a city, is a green and clean city where it has become the sustainable role model for many countries. But this thing does not come naturally. So let me share about the Singapore story. So Singapore became the independent in 1965. During the time, Singapore did not have a proper plan for sustainability where the waste can see around the road or river. So our founding Prime Minister, Mr. Lee Kuan Yew, started to enforce many laws on protecting the environment. One of the famous laws is ban the chewing gums. So it is an international job as in the world. But the government regulations also need the people to follow, and it makes Singapore become a forest city nowadays.
And how does architecture play a part in creating a sustainable Singapore?
My point of view is the technology should be integrated with nature together. Like the urban planning should consider of plant trees, green roof top of the building, or the vertical gardens. So another way is they have to rethink how to make the building more energy saving, especially converting the old buildings to the greener building. So some of the projects that I saw in Singapore is they restructure the aircon system which is a separate system, to become the centralized air conditioning with energy saving. So during the off work or the weekend, the aircon system will be switched off, where the agent energy only using where it is needed.
Wow, this is an incredible effort from government, institutions and the community. To finish off, Chai-Lun, what will Singapore be like in 2030?
Okay, so actually I'm quite happy to see that the government just announced that there's a plan called Singapore Green Plan 2030, which is a nation movement to advance the sustainable development in Singapore. So I can share about some of the highlights that I saw from the news. Like the first one is they are planned to plant 1 million more of the trees with the support from the community and the commercial groups. The second one highlight is they target to have at least 20% of school carbon to be neutral by 2030, where it is good to educate the young people with the participation from them together. As an engineer, I'm encouraging our IT engineers, if they are willing to give it a try for their sustainable technology, or they want to know how the Singapore working out this kind of efforts are, they can contact me through the IT communication team. I hope I can share with them together, or we can exchange some of the ideas together.
Wow, the move to make cities green, sustainable and pollution-free is really taking hold now. I think we're going to see vast improvements in the next 10 years. What a great story. Thank you so much for sharing it with us, Chai-Lun. So, Bobby, what's up next?
Next, well, Dan, we've got loads more examples of how engineering and technology is helping us reduce our carbon footprint, including soluble food packaging. We've said it many times over the last few years, but could this now be the end for single-use plastic?
I hope so.
Then we have the 2 marks. We've got some great engineering and tech news from around the world, with the weather map of news, and unbelievably, in the middle of a competitive season, we'll also be talking to DS Techeetah team principal Mark Preston about the changing landscape of cars, as well as the future of motorsport as it moves to a petrol-free future.
Excellent. But first, throughout this fantastic 150th IET birthday week, we've been sharing stories from our Difference Maker series. I absolutely love these. It's a great series of mini documentaries showcasing amazing engineers and technologists throughout our 150-year history to help raise awareness of some of the incredible work the engineering community has done and has really laid the foundations for what we know today.
In 1840, a telegraph line connected London to Dover and another connected Calais to Paris, yet there was no direct connection between the two cities of London and Paris. This spurred several people to propose a submarine cable across the channel. The electric telegraph was originally introduced in Britain by Sir Charles Wheaston and Sir William Fothergill Cooke. In 1837 they gave its first public demonstration with a successful transmission along a telegraph running from Euston to Camden Station. Initially the telegraph had been limited to overland use because rubber broke down when submerged for a length of time. This problem was overcome when S.W. Silver & Co. made a machine capable of covering and insulating wire. Submarine telegraphy became a reality. 2 brothers, Jacob and John Watkins Brett, took over Cooke and Wheaston's project. Jacob Brett was a younger, mechanically minded brother of John Watkins Brett. Following a conversation with Jacob, John began to consider whether, if telegraph cables could be laid, they could also be put underwater, and if so, across the ocean floor. Jacob registered a company, the General Oceanic Telegraph Company, for a telegraph link between Europe and America, but the project failed to attract public support as it was considered too risky. The brothers then made an offer to the British government to link Dublin Castle with Downing Street, but this was also declined. In 1847, Jacob patented an electric printing telegraph, which was demonstrated at Buckingham Palace on the command of Prince Albert. The application to the French government for a concession to lay the cable between Dover and Calais was granted, and in 1850 Jacob assigned the concession for a submarine telegraph connecting England and France to James Wollaston, who raised the funds and contributed himself. The Submarine Telegraph Company was established by John Brett and other investors. The company would acquire Jacob's patent for the electric printing telegraph, but the success of their 1850 attempt was short-lived. A year later, Jacob proposed a route for an Atlantic telegraph, and an improved cable by Thomas Crampton was laid by the Brett Brothers Electric Telegraph Company. It opened to the public in November 1851, and in 1853 Jacob became an associate of the Institute of Civil Engineers. The telegraph cable that connected England with France was as much a physical feat of engineering as it was a symbolic connection of peace. Britain had been at war with France since the end of the 18th century, culminating in the battle against Napoleon at Waterloo, only 36 years previously. The laying of the telegraph cable was an event uniting two historically warring nations by mutual cooperation and advances in communications technology.
Wow! Communications cables under the seas. It's hard to appreciate how these incredibly sort of early, risky and difficult solutions have played and are still playing a pivotal role in binding the world together, economically, politically and culturally.
Yeah, it's breathtaking, isn't it? Now, did you know that their first cable, the original one laid in 1850, was fully working, but a French fisherman, having stumbled upon the cable whilst out at sea, cut the cable, thinking it was a new kind of seaweed.
Oh dear.
This forced the brothers to lay a new armoured cable in 1851. And that's the difference between theoretical science and engineering. Engineers always learn from mistakes, reassess, and try again.
And that's what makes a real engineer look for a better, more effective, and often economical solution. So Dan, now it's time to look at fashion, something that's close to my heart. As you
I can tell.
And yours. It's estimated that the global fashion industry accounts for 10% of the world's carbon emissions. Production, manufacturing and transportation of the millions of garments purchased each year have been cited as some of the causes. On top of this, synthetic fibres such as polyester, acrylic and nylon, which are used in the majority of our clothes, are made from fossil fuel, making production much more energy intensive than with natural fibres. Polyester alone is estimated to use around 70 million barrels of oil each year.
70 million, crikey. Add to that the fast fashion trend that we've seen in recent years. It's reported that 85% of all textiles go to the dump each year.
85%.
Yeah.
But there are things that both manufacturers and consumers can do to reduce the impact that our wardrobes have on the climate. We are joined by three guests: Helen Lax of Fashion District, Rory Hugel from Fashion for Good, and Nick Ryan, Head of Innovation from Worn Again Technologies, to discuss what they're doing to help combat these issues and challenges within the fashion industry faces. So first, to join us is Helen Lax.
Hello, both of you. Now, Bobby, I see that fashion is at your heart, as you said a bit earlier. And did you know that your outfit today, tank tops, are dead on trend?
Oh, that's exactly what I was going for. Exactly what I was going for.
On trend, get you.
They're dead on trend. Lots of new emerging fashion designers in East London are absolutely reinventing the tank top.
That's why I'm from East London. It's all planned. It's all planned. Thank you, Helen. So having seen the statistics, Helen, this is a big problem that the fashion industry is facing. Is change really gathering pace?
Yep, it's no doubt change is gathering pace in the fashion industry to tackle all those issues that we've got with sustainability and protecting our planet, really. And some of that, I think, is because the customers are driving that. The customers really care now where their clothes come from, how they're made, who is making them, in what situation, and what they're made of. And this is very much driving brands and the industry to think through their own supply chains and the traceability of a garment. It really matters to people. And obviously, in the end, fashion is a business, so they have to take notice of that. The pandemic has most definitely brought on a new movement, a new thinking. That's also changing the patterns in the fashion industry. So things like, is it important anymore to wear seasonal things? Or can you get from your wardrobe stuff from winter, layer it with stuff from spring onto summer? Does it actually matter if you have to, change over your seasons each year? So people are buying less and buying things, fewer things, but maybe slightly more expensive things so that they last longer.
With all of these changes, Helen, what do you see the future of Fashion District looking like?
Well, Fashion District, I guess the two main things are two main jobs. The first one is pushing on the innovation, thinking about the future, thinking about how the fashion industry can respond to protecting our planet. And all along the value chain, the supply chain, what can our manufacturers, our designers, our retailers be doing to ensure that we are embedding those important values within the value chain. And so Fashion District is very much looking for, I suppose, technologists, engineers to join us in this fight and help us think through and bring forward new solutions that can be invested in and can scale up.
Thank you, Helen. So let's come to you, Rory. You work with partners such as Levi's, Adidas, Chanel, and Stella McCartney. How are Fashion for Good helping new startups in the industry to think with sustainability at the forefront of their business?
Great, thanks. Yeah, thanks very much for having me. I'd say there's four main ways in which we're trying to do that. The first of which is very important to Fashion for Good, it's collaboration. So we bring together all of the likes of those brand partners that you mentioned in a pre-competitive space. And what that enables us to do is create an atmosphere where people are sharing learnings and really driving the industry forward on an industry-wide level rather than kind of in silos. Secondly, we run pilot projects with the startups that we work with and the brand partners. And this is really important because it helps to validate the technology and demonstrate that these new innovations do work, and it kind of takes it from PowerPoint to practice, which is very important when demonstrating new technologies. And then finally, we also offer financing to these startups, which, as we know, there's a huge amount of financing that's required to bring these startups to scale and really have a kind of widespread impact. So Fashion for Good and the partners that we work with help to provide investment opportunities to those startups.
Excellent. And to you, Nick, as a relatively new startup, how are you adapting?
Well, I guess we're not so much adapting as a startup, we're actually developing for the future. Our ambition when we started off was to look at the real life problem or the real world problem of end-of-life textiles in all its magnificent mix. You get all sorts of different combinations of textiles and mixed fibers and things. And we started looking at our technology as a recycling technology to deal with that real world problem. And what we've come up with is what we believe is a relatively unique approach to this, which is using solvation chemistry, which is the use of clever solvents and clever solvent systems to isolate and extract those materials that we want to actually bring back into the supply chains.
Well, it's great to hear so much positivity and drive amongst you. Yeah. Helen, if I can come back to you. Nick touched on perhaps exploring new solutions for production processes or end-of-life treatments. How can the broader industry support the scale-up of new solutions and really influence the mainstream production?
Well, if we really want to make a difference, it's the big brands, the big retailers that need to be pumping these new innovations out. So whilst we can support startups and we can get them to a certain stage, we need collaboration in the industry between those big players and the startups so that they nurture them themselves and we get a better pipeline of startups into the mainstream. In the end, what we need is a system, a global system, not just a countrywide system, that will absolutely address those issues of supply chain, whether it's about shipping, whether it's about packaging, distribution, whatever it is, or new materials. We've got to get more collaboration to actually solve those issues. And Nick was talking about real life issues.
And Rory, I know this is something you're really passionate about, isn't it? But how do you turn passion into reality and to make that difference?
Yeah, I think it goes back to what I said earlier. It's really about actually testing these technologies in the markets and bringing all of the necessary stakeholders together. So, that's working with brands, innovators, but also manufacturers and other supply chain partners to really kind of work through the very challenging issues, especially regarding, for example, end of life, bringing together all of those stakeholders to understand what needs to be done in order to scale this technology and sharing the learnings between those different stakeholders. So that's where I think collaboration is really key and bringing all of those stakeholders around the same table to work on these pilot projects together.
Thank you. So this one is really to all of you, but we'll start with you, Nick. What areas in fashion production are the most important to tackle? And are you noticing any particular themes at present?
I mean, the themes of sustainability are absolutely shot through in the whole of the fashion industry. I mean, we started in 2011. We were not a lone voice in the fashion industry at the time, talking about the need for real life solutions to end-of-life textiles. I think the key themes now are that those recycling technologies that will come along, that will make it, have to be linked to commercial reality. We're not going to change the whole world, the whole supply chain of fashion. So what we need to do is make sure that we're not doing it in a vacuum. Helen mentioned early on, we need to make sure that we're doing it in partnership with all the big players, and we need it to be a commercially viable solution for it to be adopted, and therefore do the things that it needs to do.
Thanks, Nick. And if we come to you next, Helen, ask you the same question. Do you feel the same as Nick?
Yes, absolutely. I mean, it's a hard question, what's the most important thing to tackle? But I mean, for me, I think probably it would be new materials. Okay. And that's because we look over the fence and think about the future, and we solve the issue of how what materials we are using, then it could be that people like Nick further down the line have an easier job. So investing in new materials, especially biomaterials. The interesting thing is that sometimes when you have a new solution, you have to remember that you can't bring in a new solution that will actually give you as many issues as the one you've just got rid of. New biomaterials are really important.
Thank you. And last but not least, Rory, what are your thoughts on this?
Yeah, well, I think both the previous participants have summed it up very well, and definitely agree with Helen that, you know, the whole supply chain is rife for innovation and disruption, because there's a huge impact across the whole supply chain. And, you know, you can look at carbon emissions very upstream with raw materials, and there's significant changes needed there. And then water usage in dyeing processes at the moment. So, you know, it's very hard to pinpoint one, but I would say that the whole supply chain, really, the most upstream parts are rife for innovation, which is very exciting for us. And we're seeing a fantastic pipeline of innovators working to overcome those challenges.
Well, exciting times ahead. Well, I, for one, will be taking a lot more interest now in how I can reduce sort of the impact I make with the choices. I love my clothes.
I love your clothes. Helen loves your clothes.
Helen, thank you.
Loves your clothes.
Yours too. But finding the more sustainable options will be making me look harder from now on. It's all about every one of us doing our bit. Continuing this important topic, our next guest, Sujatha Chatterjee, founder and owner of Twirl Store, has been battling against fabric and water wastage, bringing in the idea of upcycling and recycling old clothes and transforming them into completely new garments and accessories.
She works with upcycled fabric and loves to handcraft new pieces using discarded clothes, helping to reduce cloth wastage and would have otherwise found its way to landfill.
It's crazy how we've become such a throwaway society, really. Sujatha set up Twirl in 2018. This all-women organization is not just upcycling old clothes or minimizing wastage, but also creating a livelihood for over 60 women in and around the outskirts of Kolkata. So welcome, Sujatha, and thank you for joining us. I mean, it sounds like an incredible story. Tell us about Twirl Store, and what is it and what does it do?
Thank you so much. I'm so excited to be part of this show today. So Twirl Store is basically an initiative to reduce fabric waste and benefit both society and environment at the same time. So, you know, we live in an age of fast fashion and consumerism now, where we're all shopping throughout the year. But the fact is, the World Economic Forum report states that, you know, up to 60% of the clothes that are getting produced, they actually lie around unwanted, wasted, and may eventually end up in a landfill. So, you know, we know that organizations, brands, retailers, they all have a role to play in this. But we as consumers also have a big role in this. So what we did at Twirl is we encouraged everyone to, you know, send these unwanted fabrics and clothing to us. And with all that we collect, a part of it is donated as clothing itself to those who need it, but the rest of it, we upcycle it as a fabric and make new products out of it. This entire work of upcycling, which is basically reusing a good part of an existing product, this entire work is again done by the rural women. So it enables them to have a livelihood as well. And these talented women manufacturers, they handcraft beautiful products like bags, accessories, gift items, and all these, then get sold online, offline, form part of, bulk orders, corporate gifting. And, these are beautiful handcrafted products which are eco-friendly by their very nature. And in this entire process, we're not just being able to, reduce fabric waste, but we are conserving natural resources like water. And we're also being able to, give clothing to the needy, as well as ensure women empowerment.
It's such a great social venture, isn't it? What first inspired you to set up this social venture in the first place?
So my story is really different. We tend to, have a career in the line of our education or, as per whatever work experience we've had before. I'm an engineer by degree and I used to work in the IT sector. But here I am doing this now. But the story actually started from my wardrobe. It was at one point that I just felt there were far too many things there, which I was probably never going to use again. And, I wanted to put them to a better use. So I started asking people, what could I do? And everybody said, we have the same problem, but, what are you going to do about it? And which led me to sort of start doing my own research and realize that this is actually a huge global problem. And there's far too, little work being done about it. And there's hardly any conversation about it at all. We discuss a lot of things, but we never discuss the issue of fabric waste and the impact it has on the environment. So I decided that if, I had to be the person who sort of tries to bring about a change and at least start conversations. So that was my, wish to, start Twirl Store so that people be aware of the issue and they also know that they too can, be involved in the solution.
Brilliant. And Sujata, you talked before about, the environmental effects of fast fashion and the fact that we don't talk about it very much now. How do we get that conversation going?
I think, we need to be made aware of the impact of the things we are wearing, as well as the human effort that goes into it. And we also need to be aware of the social disbalance. Many of us, we are privileged enough to have this access. Whereas many do not. I come from a country like India, where I know there are lakhs of people who struggle to find basic clothing. So we must appreciate what we have. At the same time, every time a fabric is made, it's taking up so much of resources, but we never talk about it. For example, that white shirt you're wearing, to make it, it's probably taken up as much water as you would drink in 2.5 years. But nobody's told you that. And the pair of, denims that we've just disregarded, to make and wash that, it's emitted as much carbon as going 69 miles in a car. But nobody, talks about these things. So we do not realize that as consumers, what is it that we are also doing through our wardrobe to contribute to this whole problem of global wastage, global warming. So, that is why I think, we should sort of start talking about these things. And the more we talk about it, and the more we encourage, organizations like Twirl to sort of initiate and create a change, I think, the scenario can soon change.
We can hear the passion coming through your voice as you're talking about. You are an absolute inspiration, Sujata, not just doing her bit, but employing 60 people and growing. Truly, you are a difference maker, Sujata. Thank you so much for joining us.
Thank you so much. It was a privilege to be here, and I'm really looking forward to it.
Wow, absolutely fantastic. Well, still to come. There's been plenty of skepticism about Formula E since the series' first launch. But as the world looks to steer away from fossil fuels, could Formula E teach Formula One a few lessons? DST Cheetah Team Principal Mark Preston will be with us later on to give us the answers.
Excellent. It's amazing, isn't it, Bobby, to think that electricity has been central to the IET throughout its 150 years. And a lot of people don't realise that way back in 1884, cars were already being powered by electricity. Mr. Thomas Parker built the first electric production car in London that used his own high-capacity rechargeable batteries. And now we're going full circle, aren't we? So it's going to be fantastic to hear from Mark Preston on how Formula E has overcome so many hurdles and created a truly exciting spectacle. And on top of that, Andrew will be in the kitchen with his brand of baconeering. What treats have you got in store for us today, Andrew?
Well, today it's all about structural engineering, and I'm going to be looking at reinforced caramel bridges.
Fantastic, but not too strong. I can't bite into it.
I love a bit of caramel though. Ooh. Nice. Oh, I look forward to that. And on top of that, our own icing sugar for the show. See what I did? Yeah, thanks. We have Mark to help us bring us engineering news from around the globe. Mark, where are you taking us today?
Well, today, Dan, we'll be travelling from Europe to the Far East and then stateside. We've got some great stories, so stay tuned for those later.
Don't forget that all week we're joined by IET Young STEM Personality of the Year, Callum Daniel, who I'm pleased to announce he's indoors today. Yay! Yay for Callum. Does this signify a less messy experiment today, Callum?
Yes, it does, Bobby. Hi everybody, let me tell you what we'll need for today's experiment, unpoppable bubbles. A spoon, a bowl mixer, 250 millilitres of water, 60 mils of soap, and then 40 mils of glycerin. Oh, and also cotton gloves and 2 pipettes. The first thing we're going to do is pour in our water. Now we pour our soap in. And now we add some of the glycerin carefully. Give it a good stir, but do not make it foamy. Now we're going to put our gloves on. There you go. We've got 2 pipettes, but we're going to use the larger one. Let's give it a little stir. Unpoppable bubbles.
I love bubbles. I mean, we all love bubbles as children, but it's a fantastic experiment. And there's maths behind it too. Surface area of bubbles, 4 pi r squared.
Yeah, I knew you'd get some maths in as well, Bobby, always. The IET awarded 16 world-leading engineers and technologists with an honorary fellowship for their outstanding contribution to the engineering and technology industry. One of those recognised is Professor Askwar Hilonga, founder of the Gongali model, in recognition of his model for a low-cost water purification nanofilter.
Okay, hi Hilonga, welcome. Thank you so much for joining me, and many congratulations on becoming an honorary fellow.
Thank you very much. I'm so privileged for this golden opportunity. I just received my certificate and there was a big celebration here in my office. We are so happy. Thank you very much for this award. So I invented a nanofilter. It's a water purification system that I hope you will ask some questions maybe about that specifically. But that nanofilter is my invention. It's part of my PhD studies on nanomaterials that can remove specific contaminants in water. Which is our local challenge in Tanzania. For the technology itself, what can I say? Modification of nanomaterial is not something very strange to nanotechnologists. It's just simple. It's simple. The issue is many people are not there to take action, to take heart and go into beyond the publication. So anyway, professor of what? Of large surface nanomaterials, or professor who can really make impact in people's lives. A business model like this kiosk, we make a kiosk, we put a filter in the kiosk, and then we put it in the community, deep inside the community, where there is an operator who purifies water in that community and sells water at a throwaway price within that community. So there is no transportation cost of trucks, those trucks that carry the plastic bottles that are environmentally unfriendly. And again, it's just win-win, win-win-win-win. Win for the environment, win for the job creation for the operators. Again, it's a win for the community. They get affordable water at a throwaway price. Throwaway price is affordable, isn't it? This is a beautiful English. But my pride is with this. I'm so proud of these kiosks where we sell water at a price that is 5 times cheaper than the market price. So almost everyone can afford this water, and it's spreading now. We have 127 stations, and we want to scale up very soon. So today I don't want young kids, boys and girls, to be witch doctors just because of waterborne diseases that can be prevented, contaminants from water that can be removed. We just launched a big campaign that's called Thirst for Life campaign. And I have a passion to tell you more about this campaign, but you can just go to hashtag Thirst for Life, that's one word, Thirst for Life campaign. Engineering and the science and how it is making impact in people's lives. Along with our CEO, developed different business models. That's when I saw the beauty of creating jobs for people. It's just nice. When you hear to the testimonies of these ladies, some of them are sending their kids to school just because of the jobs they got from nano-filter innovation. It's just inspiring to hear these stories. And I think for a young student who is doing engineering, this will be inspiring them to just give all of their energy to develop something that will make their life better and make people's life better in their lifetime. And that's what I'm saying. I want to be a billionaire, not in terms of money alone, but billionaire of impacting billions of lives. I think that's it's a worthwhile lifetime commitment.
Wow, what a positive impact and such an incredible, inspiring attitude.
Yeah, isn't it? And it's so infectious, isn't it? He really was such a pleasure to speak to, a well-deserved accolade.
Absolutely, and we'll be hearing from more of the 4 squared, 16 honorary fellows throughout the week, still to come on today's show. The future of motorsport, will it eventually all be electric? Will petrol be a thing of the past? I'm so excited to hear from team principal Mark Preston at DST Cheetah about the engineering and technological hurdles that he has witnessed firsthand as we head towards green and sustainable motorsport. And don't forget the latest engineering and technology stories from around the world with the weather map of news.
But before that, let's jump over to the kitchen. Oh, you need to keep the crew off this one. We didn't get a look in yesterday, did we?
Well, I'll do my best, Dan. Yesterday, I can tell you the crew do love a cake, but I'll see what I can do for you. Today, we're looking at structural engineering, and I want to look at what caramel and concrete have in common and how some sweet treats can help explain some of the incredible structural engineering in the world around us. Now, you've probably heard about concrete before. Concrete is a brittle material. It's made up of aggregate, which is effectively small and large rocks, and then cement, which binds everything together. But concrete and cement have been around since Roman times, but since then it's evolved quite a bit to be able to do taller structures and wider spans than ever before. This type of concrete is why we have structures like the Burj Khalifa and the Shard here in London. So what have engineers done to improve humble concrete to create truly epic structures? That's what we're looking at today. So to start with, I want to talk about pure concrete. And actually, a good comparison to this is just using humble caramel. So what I've done is I've created a little caramel bridge of my own, a pure caramel, which I've got over here. And all I've done is I've cast this in a silicone mold, and you can see it's lovely and see-through. All this is just sugar and water that's been heated to a specific temperature. And you'll see it's pretty thin, but I can see all the way through. And I'm going to do a really simple test. This is just kitchen science at its best. So down here, I've just got 4 little supports. I'm going to pop this in the middle. And we're going to do a little strength test here to simulate a bit of a shock loading on the bridge. So I've just got something from my DIY box, just a little bolt. And all I'm going to do is I'm going to drop this and see where it breaks. And I'm anticipating it's not going to be terribly strong. So let's go ahead and test that. Okay, can do a few centimeters, a bit higher. Still all right. Higher still, about 20 centimeters. Let's go for 30 centimeters. There it goes. So what we see here is a brittle fracture. So it's broken just like a shard of glass. And if you looked at caramel, a bit like concrete under the microscope, it's made up of lots of crystals. And crystals perform very well in compression, but not so well when it comes to tension, unless they're metallic. this is actually what the Romans found when they were using cement. That's why they had to use structures like arches, which are almost entirely in compression. You didn't see large single-span bridges. So engineers have had to be a little bit crafty. So what have they actually done? Well, we reinforce it with steel rebar. A nice way to think of this is if you imagine I've just got 4 really simple wooden blocks here. And if you imagine these as my crystals, I have to push them together to be able to lift this up, or else they fall apart. If I take something like a rubber band and I just put this around, you can imagine this is like my tensioned steel bar that I'm setting in my concrete. Then I'm able to just lift this up from either end and it supports itself. And that's effectively the role of the steel. We're making a composite because the steel performs well in tension, the concrete does well in compression, and that's reinforced concrete, enabling us to have a much lighter structure that can span a further distance. And believe it or not, we can make a reinforced caramel to test the theory. But first of all, I've got to show you how to make a caramel. So let's head over to the hob. So there's 2 ways of making a caramel. You can go for the dry route, which is just sugar. I've got about 200 grams of caster sugar here. Or you can go for a wet caramel where you add a little bit of water. Now, I find that a little bit more reliable when it comes to not getting the dreaded crystallization. And all I do is I just add a few tablespoons of water around the outside of the pan to help dissolve the sugar. Now you might be wondering, surely if I'm adding water, it's going to affect the final consistency of my caramel. Well, no, because by the time it's caramelized, all that water will have evaporated off. And this is in fact why we have different temperatures on a sugar thermometer, which correspond to different textures, is it's all to do with the percentage sugar concentration in your end product. And that's how you go from something soft, like a pouring caramel, all the way through to hard candy and caramel at the very upper end. So all I've done is put that in a very clean pan, and then the rule with caramel is just gently swirl. Don't stir, because that might create nucleation sites and you might get crystallization. So just gently swirl and keep it on a fairly high heat. So whilst that's heating up, my caramel I can pour into a bar, as the one you just saw, but I can also use it as the glue for my reinforcement. And this is where I reveal my reinforcement is in fact something ductile, a bit like steel cable. Strawberry laces. They're nice and stretchy, and they can withstand the temperatures very briefly of being dunked in the caramel. So effectively I'll be winching these through and attaching them to the bottom of a caramel bar, and that forms my reinforcement. So once that's got to a nice golden brown, we're ready for our reinforcement. So I'm going to turn that off. Now the reason why I don't put my strawberry laces straight in a mold and pour the caramel on top is they will dissolve. The strawberry laces have gelatin, so they can deal with a bit of heat, but they can't deal with being immersed. So instead, what I've got is 1 bar that I've already made of pure caramel. And remember, we want to put the reinforcement on the side that's going to be at the base, because that's going to be in tension. So I've got my strawberry laces, and you want to just cut them to measure. So these are quite long, so I can afford to cut these in 2. I'll just break them in 2 in that case. And I'm going to use 8. And just check my caramel's looking good. So just give those a little clip. And then you effectively want to be very careful because this is incredibly hot, but I'm effectively going to just drape this through the caramel. So I chose a large pan for this, and I just want to drape just the base of it into the caramel, bring it over, and then quickly set it on my beam, and then just press it down with a teaspoon just to get a good bond like that. And then I usually do it, you want to work fairly swiftly but calmly. And you want to do this roughly symmetrically, and then just press down so you get a good seal with each one. So when you've got a lovely copper brown caramel, you can just pour it into your mold, and then just pop the pan in a sink of hot water and it'll all dissolve off. So that'll set up pretty quickly, but I've got one I prepared earlier, so I'll just bring that one in. So here's my one I made earlier. It's a shade darker, but even more toasty. And I'm going to do exactly the same test that I did before. So last time it was about 25 centimeters that it smashed and it completely shattered, as you can see here. So reinforcement on the bottom. And I'm going to go straight in at a similar height to last time and drop it on top and just watch what happens. 3, 2, 1. So you'll notice I get an impact pattern which is similar to last time, but it's maintained its structural integrity. And this is exactly the same thing that happens with steel reinforcement. So if you look at concrete bridges up close that are reinforced, you'll find micro cracks in the concrete. And it's not a concern because they're still performing their job in compression. The steel is absorbing the tension. You're now at the point where we've got some self-healing concretes that can fill those gaps, but it performs in exactly the same way. It's why you have those lines in the windows at school, safety glass, so that if it gets hit by something, it can crack, but it doesn't shatter and release the pieces. So next time you're making a caramel cantilever, make sure to include some edible reinforcement to make it go the extra mile.
It's a far cry from Mrs. Beaton's cakes from back in 1861. It's unreal, isn't it, that she was writing cookbooks when the IET was still only just a dream. And 150 years on, and we're here celebrating the IET's birthday. I'm sure she'd been impressed with Andrew. What do you think?
Oh, definitely. We're always impressed with Andrew.
Yeah, absolutely.
So it's time to start your engines well. Flick a switch and get fast and furious with Mark Preston, team principal to the most successful Formula E team to date. That's not 1, not 2, but 3 back-to-back drivers' crowns and 2 teams' titles since 2016. He's also worked in Formula 1, so he knows both sides of the petrol-electric coin.
Oh, so exciting, isn't it? I mean, it's literally fresh from his team's latest win in Monaco. We are so honoured to have you with us, Mark, to celebrate our 150th anniversary, especially as the season's still underway.
Yeah,
Come on.
It's quite exciting, and obviously winning in Monaco is incredible. It's the best fun ever.
Oh, I can imagine, yeah. But let's start at the beginning. You grew up in Australia.
Correct.
Was motorsport something you grew up with?
My grandfather was actually a wrecker, so wrecking old cars, and our family had some farms. My uncle had a farm, and we lived on a farm when we were young, and so we were pulling apart tractors and those kind of things when we were young. So I got into vehicles and fixing things early on.
Yeah. Excellent.
Yeah, so I guess you had this early fascination, and then you went on to university, studied engineering. But how did you get into motorsport? Because it's not like a straightforward industry to get into. So how did you go about that?
Well, it's funny, my degree at Monash University was reasonably a theoretical degree, and I decided I wanted to do some more practical things. And I found there was one company in Australia that manufactured race cars, and actually they weren't at the time, called Baldwin Racing. I rang them up and said, can I come and do some work with you while I was at uni? And they went down there, and I remember the first day they asked me to do something, and I did it and came back the next day, and they went, oh, we didn't think you'd come back the second day. Not everybody comes back the second day. Yeah. And then sort of 7 years later, we'd started to win some things in Australia. And when I was about 27, I thought I need to go to Formula 1, and I came over to work for Arrows Grand Prix in the UK.
Wow. And of course, now currently you are team principal of Techicha Formula E racing team. What's the difference? Tell us more about e-racing and how does it differ from Formula 1?
Yeah, so there's quite a lot of differences. Some of them are quite technical, and I'm sure you don't mind the technical things.
We love it. We love it.
So one thing is we have peak power. So we can limit the power because it's a battery, and you can say this is how much power you can take from the battery. So it's a big difference to a petrol-powered motorsport where you basically give a certain amount of fuel, make as much power as you want, and that means that across the grid, that can vary quite widely, and that's why you see a lot of differences in the grid in something like Formula 1. We have very restricted aerodynamics because, again, we want to focus on the electric powertrain because that's the thing that we need to develop and to grow. So everything's really focused on the electric powertrain and the software around that electric powertrain. The other things are that we race in cities, so we're obviously in Monaco, similar to F1, although we had a lot of overtaking in Formula E. Wait to see what happens with Formula 1 in the next weeks or so. And we do everything on one day, so it's very compressed. So whereas in most petrol-powered motorsport, you start on a Friday, you do practice, then you go to qualifying on a Saturday, then you race on a Sunday. But for us, it's all in one day. So actually, it shows up the best drivers because the driver has to arrive and basically deliver in one day. So there's some of the the biggest things that are different about Formula E.
Excellent.
Yeah, that's really interesting. Actually, what we sometimes find is that a lot of motorsports enthusiasts actually they're really against the electric racing scene. So, like, do you prefer like the noise and the heat from a petrol car, or have you sort of grown to love the all-electric scene?
I mean, I love technology. So, as being an engineer. I think that with an electric powertrain, you can actually do more things than you can do with a petrol powertrain, because in a petrol powertrain, you have to worry about the clutch, for example. So when you're doing a launch or something like that, you've got to get the clutch to bite, and that's what you see a lot of the F1 guys doing, where they come to the grid and they have to find bite points and all sorts of things before you can control the launch. But in electric, it's got power from zero. I'd love to do one day a full four-wheel drive electric vehicle, which has got, you can control electric motors better than you can control a powertrain, such as a internal combustion engine. So from a technical point of view, I think there's more room to move in an electric vehicle in the future.
And that's got to be good for all of us, hasn't it? I mean, we've heard quite a lot throughout this show about society's need to embrace more sustainable options where possible. What drives you, no pun intended, in pushing the boundaries for sustainable motorsport?
I mean, it's great to be sort of relevant, I think. Relevance is the really key factor, I think, in motorsports and probably any sport. So being more relevant, and for me, it's always pushing the boundaries. I mean, in one of the presentations I do, if you remember back in 2009, Top Gear had this crazy car that they built on the show that they made out of old generators and all this kind of stuff. It was an electric car. It's scary how long ago that was now, actually. It's in one of my presentations. But coming from, say, 2009 to now, when there's so many more electric cars on the road, there's obviously, we've been racing now for 7 years in Formula E. It looks spectacular on the weekend in Monaco. Things have changed a lot, and it's, you know, when we started doing Formula E, people really did think we were crazy. I mean, when you look at that show on Top Gear, and you think that's what they thought we were doing, and then to now, when, you know, we look, I say, incredible on the TV, it's amazing to be involved in something that's changed so much over, I say, just 12 years, but 12 years is a long time, isn't it? So that's the other thing that's, I don't know if it's frightening, but how long it takes things to change. You think it's happening fast, but actually it's been a long time already that electric vehicles and race cars in particular have been coming. So I enjoy being at the forefront. I do still like classic cars and those kind of things, but I enjoy being on the very, very cutting edge, where I would say nobody knows the answers. That's always the fun bit, where, for me anyway, when nobody knows the actual answer to all the questions, let's say.
Actually, as a maths teacher, I find it unsettling when I don't know the answer. But anyway, so looking ahead, what does the future of e-racing look like? So do you think it'll always be battery technology, or will we see hydrogen making an appearance? Like, where would you like the future of motorsport to be?
Yeah, I think the best way of looking at this, in my opinion, is that I think it will always go towards an electrified, let's say, drivetrain. So like a diesel electric train, the electric power is used for what it's good at, which is torque from zero. So you can even see in Formula One already that many of the KERS systems and other things are all on the drivetrain side. Then on the other side, you've got the energy carrier, as VW likes to call it. So how do you carry your energy in your vehicle? I think that'll change depending on what country you're in. So in France, for example, they have a lot of nuclear power. So it's fairly clean from the point of view of CO2. The UK, I mean, the amount of wind turbines we're putting in over the next years, we're already, if you see, on some days we're above 50% renewable. There's countries like Portugal, which are really high in the renewable stakes. But then you've got a place like Japan, which doesn't really have a lot of space for wind turbines and other things like that. So they're more biased, although because of some of the problems recently, towards nuclear. But they're heavily looking into hydrogen because they're one of the biggest importers of energy in the world. So long story short, I think places like where I'm from in Australia, with the vast spaces and the possibility of wind and solar, then converting that to hydrogen, and then perhaps to things like synthetic fuel, which Formula One's looking at. So even they're starting to figure out how can they go more sustainable. Again, it's quite exciting, all the possibilities. They're obviously not as efficient as direct electrification is at the moment, but you never know, because one day you think something's not possible, and then 5 years' time something is possible. So to answer your story, your question, I'm excited about what it might be, and that's how I can see it. All the building blocks might go together in the future.
Brilliant. And in your spare time, I don't know how you managed to do this, to be honest, you also run a laboratory, don't you, in Oxford, that studies the future technologies as well. Have you got any exciting innovations coming out of that you can tell us about here? Break some news for us.
So we do autonomous cars there. So we're actually doing something to a truck up at Sunderland in one of the manufacturing plants at Nissan, which is an autonomous yard tractor, they call them, terminal tractors. So we're doing that. So it'll be a truck that pulls around trailers in the grounds of the manufacturing plant. So that's all, let's say, the next step in electrification and autonomy. So I think in some ways you could say that autonomy might be EV's killer app, if you remember what that was called in the old days. So some people don't know what I mean when I say that. So I think, yeah, the autonomous vehicles are the next step. So yeah, quite exciting what's going on in the UK.
That is exciting, really exciting.
Actually, cheeky question. I've never actually driven a race car. Is it beyond the realms? You know, you'd make a lovely IET.TV video.
Oh, I was going to ask that.
Yeah, you can go second after me.
Well, one way of looking at it is that, you know, you could say they're like astronauts, our drivers. So, you know, would you get to fly the space shuttle? That's one way of looking at it. But yeah, there's possibilities of driving.
The tourist, you know, the tourist version of astronauts.
Yeah, exactly. You can definitely go for a ride in maybe in the pace car. So you know that's definitely a possibility in the safety car. But yeah, there's always possibilities. You never know of having a driver an electric race car.
Yay. You never know, right? We've got Mark saying you never know. We could be it. Oh, thank you so much for coming in and sharing your story with us and coming in straight after your amazing win. Congratulations as well. You've been an amazing guest and such a difference maker. What a difference maker. A brilliant guest for us to have on the show for our 150th anniversary. But still more to come, Bobby.
Excited, yes, from sustainable sport to sustainable food packaging. Our next guest, Ivan Ling, was the winner at the IET Global Challenge in 2019. The competition, in partnership with Greenpeace, was created to encourage young entrepreneurs to design innovative solutions to save our seas and solve real-world plastic and toxic waste threat. The Greenpeace Challenge asked for ideas for reusable packaging designs or new approaches for supermarkets to dramatically reduce their need for plastic packaging. The winning entry was by Team Nano Malaysia, and we have team member Ivan with us. Hello, Ivan. So let's start with your global challenge innovation. Was this something you came up with for the competition, or have you been thinking about this before, and sort of how did you go about creating it?
What we are actually doing is we brainstorm this idea just for the competition, because we were really thinking about how we want to reduce waste, and we thought maybe we should come up with some sort of biodegradable packaging, but a lot of people are already doing that. So that's where one day we're having snacks. We're eating this Indonesian food called tempeh. So it's a bunch of beans fermented. It's kind of like Japanese natto, where the beans stick together. And we're looking at it and we're thinking, hey, is there a way we can create a new packaging method that sticks all this bean together so we don't need plastic bags? And thus, we started embarking on this journey to create the PCAST block that we submitted for the Global Challenge.
That's brilliant, and it's such innovative thinking, isn't it? What made you apply for the Global Challenge in the first place?
Well, I'm a long-time member of the IET, so when I saw this Global Challenge and when I looked at the entries from past winner, I was really impressed, and I thought, hey, I want to be part of this, right? But I didn't really get a chance until 2018-19, when I formed a team. So my team members and I, we met in the Malaysian Nanotechnology Olympiad. So we entered another competition. So after that, we came out and we thought, hey, we need to find another competition. What's next, right? So this is where I saw the advertisement from the IET, and I told them, hey guys, look, there's this global challenge from the IET, and we are a bunch of scientists, right? During that time, I was in my final years of the PhD, and our group is made of like PhD students across different universities, and we're thinking, hey, is there a way we can use our knowledge on polymer, on nanotechnology, on this material science? Is there a way we can combine all this and come up with a solution? And thus, we went into Global Challenge with no real idea at first, but then as I mentioned earlier, we brainstorm and inspirations come to us, and hence we came up with this really amazing idea of packaging beans and other loose food items in carrageenan and starch.
Brilliant.
Yeah, really brilliant idea.
Yeah.
I love the idea of the collaboration with different universities. But for you, Ivan, what was like the most difficult part of creating that sustainable food packaging?
So the first part is actually getting the materials right. So we were trying a lot of different materials. So it took us a lot of brainstorming. So gelatin is a good material, but it doesn't work. Then we started looking into different like agar. So agar is a bit too fragile. Instead, then we started looking into carrageenan, which is a jelly, basically, like Japanese konnyaku, right? So we bought in samples of carrageenan and we dried it, and apparently it worked. But then the drying process brings another challenge, because when we're drying it too fast, turn on the high heat, it cooks the bean, right? So we wouldn't want that. So we turn the heat down a notch, right? But if you dry it too slowly, the water from the carrageenan, because it's a hydrogel basically, right? The water from the carrageenan will seep into the bean, and the bean starts to germinate. So we have to play around with number one, the amount of water we use, right? The amount of gel that we use, and then we have to figure out a way to like heat it up consistently without cooking the beans, and to make sure that it dries, before water gets into the bean and starts to germinate. So I would say that is definitely one of the hardest parts. Lots of experimentation.
That is amazing. What an amazing story. And great to hear that you've gone from IET Global Challenge to even more, and it's really sort of been a big springboard for you. That's great. Thank you so much for sharing your story with us. It's been an incredible story. Thank you.
No problems. Thank you so much for inviting me.
So from one great news story to 5 more.
5 more, I like the sound of that. So Mark, it's that time again to see where the hottest engineering and technology news is at the moment. Are you going to drizzle some sprinkles on top of an already fabulous show?
I'll do my best for you, Bobby. Let's spin that globe. And we're starting in Japan today. The country has been accused in the recent past of not investing enough. Well, now they have some huge ambitions for the future, and they've said they hope to create 20 unicorns by 2023. That means we could have real-life unicorns in just 2 years. No, really, the government in Japan is investing huge funds into startup companies, mostly in the technology sector, to really drive the growth of their economy. And we're going to go to the USA, and it's Missouri, where researchers from Washington University have found a way to store energy in the bricks that are used to build houses. The scientists claim that walls made of these bricks could store a substantial amount of energy and can be recharged hundreds and thousands of times within an hour. Amazing. Back across the Atlantic and in the UK, it's smart materials company Chimera, and they're developing heart monitoring t-shirts. This new t-shirt will accurately measure heartbeats and upload them to the cloud via Bluetooth. Once there, algorithms process the data to accurately detect irregular heartbeats, which could prove to be life-saving. And where we go next, it's just over the channel there to France, where a team of French designers have created a tattooing robot that draws perfect artwork right onto your skin. The machine combines a tattooist needle and a 3D printer. A piece of software lets you take any image, whether it be a photo or a sketch, and then insert your limb into the printer. The needle will then automatically move across the skin, puncturing the skin up to 150 times per second to create the permanent design. Something you'd have a go at, Dan?
No, Mark, I would not try. The engineering, the tech behind it sounds great, but no.
Well, let's see where we're going next. And finally, it's China. And they're planning to build a super solar expressway for self-driving cars and electric vehicles that will be able to charge them as they drive. No more stopping to charge your car. The panic as that needle drops will be a thing of the past. Dan, is that essentially a bumper car with batteries? Now that would be cool.
That would be great, Mark. Another great set of stories. Thank you. So, Bobby, what a show. So many highlights. Great baconeering from Andrew. Callum was awesome, again, with a fab experiment. And a guest list that we at the IET in the 150th year will never forget.
Dan, it's been another brilliant episode. Some amazing stories. I've learned a lot. and it's really made me think.
Yeah, me too, totally. The world of engineering and technology never fails to excite and inspire. So thank you to everyone who has tuned in, and we will see you again tomorrow for another hour of Difference Makers to celebrate 150 years of the IET. Thank you once again, Bobby, and to all of the team for guiding me through. To all our viewers, have a safe rest of your day, and we'll see you at the same time tomorrow. Bye.